Hello my dear students, welcome to the ASD physics classes. Hope so, doing really great. Today we are going to solve the questions of gravitational potential energy. We are going to solve JEE questions and they are important for the NEET exam also. Okay, so students, let's start one by one. So the first question is JEE 2023 question. Let's go through it. A body of mass m is taken from Earth's surface to the height h equal to twice the radius of the earth. The increase in potential energy will be how much? Okay, so according to the question, what is there here? One object is there at the surface of earth. Okay, after that, what is there? We are taking it to some height. How much height is there? H equal to 2 RE. In the question they mentioned it twice the radius of the earth. Okay, so let's take here this point is A and here this point is B. So how much increase in the potential energy? So students, the concept is that when the kinetic energy of the object is constant, then work done by the external force will be equal to change in potential energy. And for that you have to just remember the formula mgh by 1 plus h by re. Okay, now in the question what they are telling? They are telling h equal to 2 re. Now this value I will just put here, so I can write here mg, here 2 re 1 plus, so h by re from here how much here? 2. So when you will simplify this, it will come 2 by 3 mg re. Now very easy, you have to just remember this formula. Okay, next one students, let's see the question based upon the escape velocity asked in the JEE 2024. So the question is, escape velocity of a body from earth is 11.2 km per second if the radius of a planet be 1/3 of the radius of the earth and mass be 1/6 that of the earth, then escape velocity from the planet how much? Okay, so what we have to do? First we have to note down the data here. So here they have given escape velocity from the earth. How much given? 11.2 km per second. That we know also. After that, if we talk about the radius, so radius of the planet, how much given? 1/3 of the radius of the earth. That means we can write here RE by 3. If we talk about the mass, what about the mass? Mass is the 1/6. So mass of the planet is 1/6 of the mass of the earth. Now, this is the given data. After that, what we'll do here? Just guess the escape velocity formula in terms of mass and radius. Okay, so here escape velocity formula is given here. Since escape velocity is equal to √2 gm by r. Okay, so here you can see 2 is constant, g is constant, so we can tell here this escape velocity is directly proportional to mass by radius. Is it? Now what we will do? We will just make this formula in a ratio form. So what is the ratio form here? We can write here escape velocity from the planet by escape velocity from the earth is equal to square root, mass is directly proportional, that means this side here, mass of planet by mass of earth into radius of the planet is inversely proportional r. So here it will become here radius of earth by radius of planet. Is it? Now just put the values here. So mass of planet by mass of earth, how much here it will come here? It will come 1/6. 1/6 into RE by RP will come from here how much here? Just see here please, it will come 3. Is it? So it will come here, when you will simplify this, it will come here 1/√2. Now after that, next one. So escape velocity from the planet is given by escape velocity from the earth by √2. This value how much given here? 11.2 km per second. Is it? So we'll write here 11.2 by √2, and when you will simplify this, it will come students 7.9 km per second, and √2 value you know very well, 1.414. Okay, so the correct answer is here option D. Okay, see how much easy way we are going ahead. Next one students, JEE 2022 question and important for the NEET. Is it? So see please again question. The escape velocity of a body on planet A is 12 km per second. The escape velocity of the body on another planet B, whose density is 4 times and radius is half of the planet A. Okay, so here what we have to do here, again we have to note down the data here please. Now, so see please, escape velocity from the planet A, how much given in a question? 12 km per second. Okay, after that, next here, density is 4 times. Now, so density of the planet B, how much here? 4 times. So rho b is equal to 4 times of rho a. And radius is what? Radius is half of the planet A. So radius of planet B is the half of the radius of planet A. This much data is given, and what we have to calculate? We have to calculate escape velocity from the planet B. Okay. So what we have to do again, students? We have to write the escape velocity formula. But this time in a which form? We have to write in a density form, because in the question they are telling density. Okay. So this formula you have to remember that here. Escape velocity equal to 8 by 3 pi rho gr square. Okay. So here what will happen that here? Other things and all is constant. So V is directly proportional to rho r square. Square root of r square means r. So it will become here r into root rho. Now again what we have to do? We have to again do in a ratio form, students. Now so let's do the ratio form here. So escape velocity from planet B by escape velocity from planet A. So radius directly proportional anyhow. So RB by RA. And the density also root rho B by rho A. Okay. Let's put the value from here. From here, students, RB by RA, how much here? 1 by 2. Is it? And here, if we talk about here, rho B by rho A, how much it will come here? Root 4. No? Root 4. So we can tell here 1 by 2 into 2. How much coming? 1. That means escape velocity from planet B is equal to escape velocity from planet A. And the value how much given here? 12 km per second. That means here what will come? 12 km per second. That means value will be what? The value will be unchanged. Correct answer is here what? The correct answer is here option A. Okay. Next one, students. Now JEE 2022 question is there, and here we have to use the basics of the gravitational potential energy. Okay. You have to remember that when two masses m1 and m2 is separated by distance r, then what is the gravitational potential energy formula? Minus g m1 m2 by r. And here we have to see the number of pairs. Number of pairs formula n minus 1 by 2, where n is the number of masses. So let's see here please question. 4 spheres, each of mass small m, from a square of side D as shown in figure. A fifth sphere of mass capital M is situated at the center of square. The total gravitational potential energy of the system, how much? Okay. So here, please remember that one thing here, how many masses are there? See please, 1, 2, 3, 4, 5. So number of masses is 5. So hence, number of pairs will be how much? Number of pairs formula, n minus 1 by 2. Put n value 5. So 5 into 4 by 2, 20 by 2. That means how much? 10. There should be 10 terms should be there. Okay. So after that, let's write here. Now we'll write here the potential energy. U equal to potential energy will be always how much? Minus. Okay. So first one we'll see the side masses. Now this m, this m, this m, and this m. So distance between these masses how much here? M and m separated by D. Like this, how many is there? 4 is there. That means we can write here minus 4 gm square by T. Okay. Next one, after that, students, we have to see the which one diagonal wise here. This m, this m, this m, this m. How many pairs are there? 2 pairs are there. That means we have to write here minus 2 gm square by d root 2, because this is d, this is d. That means this total distance how much? D root 2. That means total how many terms are there? 4 plus 2, 6. Still how many terms are pending? 4 terms are pending. And where are these 4 terms are there? These 4 terms are here with this capital M. Okay, because this capital M is making 4 pairs. See, first pair, second pair, third pair, and fourth pair here. Okay, so here what we can write here. Now here what we can write here. This is the minus anyhow. So minus 2 G capital M small m. 2 or 4 pair? 4 pairs are there. Now 4 pairs are there like this 4. And this distance how much? Just guess please. This distance, you know this distance, d root 2. So this distance how much? D root 2 by 2, or we can tell d by root 2. So here I will write here d by root 2. Then you have to just simplify this. You will just get the answer. Okay, students. Now, great. We are going great. Is it? Next one, students. JEE 2022 question based upon the escape speed basics. We have to use it. Okay. So see the question, students. A body of mass m is projected with velocity lambda VE in vertically upward direction from the surface of the earth into space. It is given that VE is the which velocity? Escape velocity. lambda is less than 1. If air resistance is considered to be negligible, then the maximum height from the center of Earth, from where they are asking, from the center of Earth to which the body can go will be. Okay, so first we are going to do here, let's take here, this is the surface of Earth, is it? And I have taken here point A, and from here we are going to project one body. How much speed is given? We are going to project now. Let's take, I have written here the U. Okay, how much given here? It is given here lambda VE, no? Lambda EVE. Okay, so what will happen that here? It will just go upward direction. Like this it is going here. Let's take here. At point B, what will happen? When it will reach to the maximum height, the velocity will become how much here? 0. Okay, and as we have to calculate the distance from where? Distance from the center, that means this distance we have to calculate small r, because in the question they are telling. So students, remember that one thing, as in the question they have mentioned, there is no air resistance. Air resistance is the which kind of force? Non-conservative force. It is not present. That means what will happen? The energy will be conserved. Which energy will be conserved? Mechanical energy will be conserved. Okay, so from the conservation of mechanical energy, what we can write, students, here? Let's take, this is the point A. Already I have told you, no? This is point A. So what will happen? Energy at point A is equal to energy at point B. No? Correct. Energy at point B. Mechanical energy means which energy is? Potential. That means UA plus KA is equal to UB plus KB. Now after that, potential energy at the surface of the Earth will be how much? You know the formula very well. Minus G capital M small m by R plus kinetic energy how much? Let's see here, please here. Half m U square is equal to, now potential energy at point B how much? We have to take all the distances from the center from here. That means we can write here minus G m by small r, and kinetic energy how much? The kinetic energy will be 0. Okay, so this is the expression. We have to just simplify this. Okay, so we have to just move to the next page here. So again, let me write the expression here. Minus G capital M small m by r, this was the potential, is it? And let's go to the back here, and half mu square here. Now half mu square is equal to minus G capital M small r. Okay, so what I am going to do here, this one I am going to send this side here. So what this will become here? G capital M small m 1 by capital R minus 1 by small r is equal to half m. What is U? U is given lambda into VE. That means lambda square into V square. Okay, now we'll simplify this here. This means very easy, very easy. We have to just do the calculation. So it will come here 1 by R minus 1 by R is equal to half m lambda square. Escape speed formula, square is there, that means 2 gm by R. Now what we'll do here? We will just cancel the things here. Now, so G capital M small m, G capital M small m cancel out here. After that, this 2 and 2, this 2 and this 2 also cancel. Very easy. Now after that, let's write down here 1 by capital R minus 1 by small r is equal to what this will come here? Lambda square by capital R. Okay, now what will happen that here? 1 by R, I will just stop it here. So what this will come here? 1 by R minus lambda square by R. Okay, so we can write here 1 by R is equal to, what is the things are common, students? 1 by R is common. That means what is left here? 1 minus lambda square. Okay, so hence what is the value of R? Small r will come here, capital R by 1 minus lambda square.